Hello, this is a quick video about migrating your work from Udacity workspace to SageMaker Studio. Some of you have consumed all of their credits and the all of GPU hours, I'm sorry. So this is a project itself in the Udacity workspace. We can open it in a new tab just by clicking Jupyter's and open in a new tab. This will open the project but in another tab to handle the directories more clearly and have a better look. We can open any notebook and at any empty cell or in any empty cell we can execute some couple of lines to save the current files and compress them in a zip folder. For example, here we are getting the current directory, creating a file called compressed files.zip that will hold the zip format or extension and also the files inside. We can create or run this command and go to the home directory to see that the file is already created. We can click this file and download and for example in the desktop we can name it compressed files. And once it's downloaded, we can go to the folder that contains that file, and we can extract its elements to see that, or to see whether the elements inside are similar to the elements in the Udacity classroom. So we can check right here. As you can see, the checkpoints folder exists that contains the already trained models. And the source file contains all of your Python codes that contain some tasks you need to finish. Also, you can see the app CNN from scratch, transfer learning notebooks. These are the three main notebooks that you need to finish or finalize. The requirement to text file contains all of the libraries with their versions that you should install to be able to finish the project. That is it. We can now go to our SageMaker Studio. This is the interface of SageMaker Studio. Go to your main directory, create a folder, and this folder can be named Project3, for example, and here TF for transferred files. And as you can see, this is an empty folder. We can now upload our files, compressed files from the desktop. Once they are uploaded, we can create a new notebook. Click on the plus sign here, and it will give you some options to consider. We will create a notebook, and it can be Python 3, kernel, data science 3, no problem. It's an MLT3 medium also instance will be by default created. This is okay. We can now write some other code that will unzip the uploaded files for us in the same directory. So basically what this code does is that it gets a file that's named compressed files.zip in the current working directory, and it will unzip it in the same directory, and it will hold the name of, let's see, it will hold the name of unzipped files, and that's it. Here it will make a directory that will hold this file name. It will be called folder name. It will be called unzipped files, inside of which you will find all of your unzipped files. And that's it. Let's wait for the kernel to start. Okay, now we have our kernel ready. We can execute this command. As you can see, the folder that contains our files exists. As you can see again, the checkpoints folder here and the source folder that contained our Python codes and so on are here. So let's start our project. Let me go to a project that I have already been working with. this one over here. I went through the same steps, but I made it even more ready for what's coming. I think we don't need this notebook anymore. We have our files already right here. So if you're still in the CNN from scratch step, then you can choose whether to work on a CPU or a GPU, and it's better to work with a CPU, especially if you're running the first couple of cells that do not need any heavy computational power. So you can go with a kernel type or an image type of PyTorch 2 or PyTorch 1 CPU. However, if you are trying to use a GPU, you can choose this kernel. Okay, I'll choose this one for now, Python 3.10, PyTorch 2, GPU. And automatically, when you choose this image, you will see that the instance type is MLG4DNX large, and this is the least or the least heavy one in terms of computational power. So if you went right here under accelerated computing, you will find that we have 2x large, 4x large, 8x large, 12, 16, and so on. And we have the one that we are using right now, which is only 1x large, but they all lie under the section of accelerated computing instances. So we will choose this one. This is again is the least heavy one, and to see its pricing, uh, we can do what we can check the pricing here. Mm, here using this link, SageMaker pricing list. MLG4D NX large costs you $0.7 per 1 hour, and this is okay with us. We can choose this GPU. Okay, we can start it. It will take, of course, some time. As you know, the first couple of cells, again, do not need any CPU. However, when you come to the training step, which is step number 5 and step number 6 for testing, you can enable the GPU and be careful that the same instance that you will use for training should be the same that you will use for testing. So when you use or merge to a GPU, you have to use it for step number 5 and step number 6 as well. Testing against the test data set, and test, of course, for step 7 you will need it as well, I think. And that's it. So keep the GPU for step 5, 6, and 7, and let's give it some time to start. Now our instance is ready. We can go through the first couple of cells that install the libraries or the required libraries, and also the setup environment which downloads the dataset for us. So here the dataset is downloaded, landmark images, and here it states that the GPU is available. And let's go to the training step to see how fast the training process is. So this is step number 5. Let's run these cells. So here is our training process. And actually this instance is fast. And it's recommended also to run your training for 100 epochs minimum. Also don't forget to use reduction of learning rate on plateau of validation loss. This will be very important. Also having batch normalization layers and the architecture of your CNN is very important for better results of the accuracy on the testing dataset. As you can see, these two graphs will be plotted automatically based on your training. They are included in the train.py file. They are showing, of course, the losses against the number of epochs and also the learning rate against the number of epochs. And the learning rate will not be fixed all of the time. It will get reduced. This is a task actually in the project, how to reduce the learning rate when you notice a plateau in the validation dataset. So you have to take care of that. And this is a second epoch. Okay, so you will see that this curve or this graph will keep updating till the 100 epochs finish. So this is the first two epochs. Our training loss was this value at the beginning of the blue line, then it became this value at the end of the blue line, and the orange line is for the validation loss. I think it's the training of this instance is fast. So when you're done, don't forget to close all of your instances from here, shut down all, and also from here. That's it. One other thing, I will share this Word file that contains these codes. The first code for downloading files from Udacity workspace to your local computer. And the second one is for unzipping files in SageMaker Studio. I hope it helped. Please reach me via our regular communication methods in case you have any question. Thank you. Bye.